Okay, so this is how to create the orthographic projections for this part, and I'm calling this part number 6. So it says to create a computer model of the part shown below, use 3D modeling software, and create a fully dimensioned part drawing to represent the part using the appropriate dimensioning techniques. Dimension the cylindrical features on a view in which they do not appear as a circle. Okay, so then it says to refer to the dimensioning standards PowerPoint. Okay. So in this case, use a reference symbol to dimension that indicates the exact number of occurrences using the X symbol for each repeated feature. Okay, and assume that all the holes are cut completely through the part, and indicate this by adding the word through after the hole diameter in the dimension note. Okay, and then print and save your different drawing file. So let's take a quick look at that PowerPoint. So what it's referring to is this slide right here, that cylindrical parts can be dimensioned. Right here, you can't exactly tell that these are circular. Okay, and I gave the example that this kind of looks like the end of a battery. So right here, you have that end view where it shows that it is actually circular. And right here, you can't exactly tell, but it does indicate that through the use of a diameter symbol right here and your center line. So let's do that in Inventor. Start my new CDP title block, fill in all of this information. Okay. So right here, I'm going to go and I'm going to actually find where my part is located. And for this one, it should be part number 6. So there's a couple different ways that you can do this. You can choose this one as your front view, or you can choose this as your front view. I'm actually going to put this one as my front view for right now. And I'm going to bump this scale up a little bit since I'm only going to need 2 views anyways. Okay. And I'm going to project those other views. Projected. I click create. Okay. So from here, what I need to do, I need to start by dimensioning these circles right here. So I'm going to dimension one of these. So I'll dimension this. I'm also going to dimension this diameter here and this diameter here, making sure that these two don't actually run into each other. Bump this down just a little bit. I'm going to change the scale on my isometric. Make sure that it's shaded. All right. So then I have circles here, so I need to make sure that I add center lines to my circles. I'm going to add a big center line here, and I'm going to add a center line to all of these. And I'm also going to add a center line right here. So center line between, actually I'm going to use this one, so that way I can draw it to here, and then left click to place that. And I'm going to put a center line between here and here, and here and here. So what I also need to do is I need to have a center line that shows up around these 3 holes for the circular pattern. So you're actually going to use this center line command right here, and you're going to click on the center, the center, the center of this one, and then complete that with the center of this one. So it should create that circular pattern right here that you can use to show where exactly these holes are. Oops. Need to make sure that I actually finish the command. Click here, right click, create. There we go. So now when I hit escape, that should stay up. So I know the diameter of this right here. I know the diameter of this outer circle right here. I need to indicate some more information about the holes on here. So this right here has a diameter of 0.17 inches. So I should be able to say 3 times that diameter all the way through the part. I know the diameter of both of these. This hole is centered from here to here, so it's halfway there. So if I take a second to look back at the original dimensions for this part, I still have to add the thickness of these. I also need to add the radius from the center to this center line. So notice in this instance it's okay to dimension to the center line because we need to know where that distance actually is. And then right here you can see that my decimal place is 0.172 and that these ones also show to 3 decimal places on a few of these actual dimensions. So I'll show you how to change those as well. So going back to Inventor, I'm going to double click on this one and I'm going to change my precision and tolerance to my primary unit to show 3 different decimal places. So notice how that changes it right there. Okay. I have those 2 dimensions right there. I'm going to dimension the thickness of this. I'm going to do baseline for that. So from here to here and to here, right click continue, left click, right click create. Make sure that this is in between there. That looks pretty good. And then last but not least, I need to know the dimension on here, but I'm going to know from here to here, and that should allow me, you can even do an offset dimension if you wanted to as well. So that one would be perfectly acceptable. And then you can actually take this and bump it out. So that's one way in which you could do that. You could also dimension the diameter on that one, or you can try and play around with it and see if you can get an actual radius to show up instead. So you might be able to do something from the center to here to get some sort of radius dimension. Okay. But something like this would be fine. I'm going to bump that one out to 3 decimal places as well. Okay, so I know that that's offset right there. And last but not least, I need to make sure that we know that there are 3 holes here and the angle between those. So I'm going to dimension between here, here, and here, and I should be able to show the angle of those there. So notice this is saying 120 degrees. If I go this way, using this point right here and this point right here as my 0 degrees, that's why this is showing up as 60 degrees in this direction. Okay, because it's using these 2 right here as my 0 degrees or my horizontal axis. So I can place that. If you want to click in a different order, you might be able to get it so it shows up on the other side. So if you wanted to do that 120 degrees, because 360 is divided by 3, you get 120. But this method right here, because these 2 are in alignment, which means that there's 60 degrees between this one right here and here, and between this line right here. So if you wanted to, you could take these and kind of move them around a little bit. So looking at this part, I have all of my holes have center marks. The larger outside one has a center mark. These all have center marks within them, or center lines. The thickness is clearly displayed of both of these. We know that all 3 of these holes go all the way through. Just kind of bump this up and over a little bit. Maybe just place that up a little bit higher. But for this part right here, that looks pretty good. If you need to check any of your title blocks, you can go over here under the Homer in the browser right here, and under field text, you can click there, and you can change any of the properties in here you might need to change. So you can actually type your name, your scale, make sure that it actually matches what yours is. So let's double check that. So 2:1. I'm going to go back over here, type in your name, scale, 2:1, revision number 1. I'm going to put number 6 because this is part number 6. Say OK, and print it out, and you are all set.